All right, today we're going to solve exponential equations. And in order to do that, we're going to eventually have to convert these problems into logs. Just like how when we solved logarithmic equations, we eventually had to convert the equation to exponential form. So let's look at this system of equations, and we'll set them equal to each other. So the first thing you want to do is get b to the x power by itself. Now, b to the x is just general. You could have like x plus 7 in the exponent or 3x as your exponent. You want to get your base, and your base raised to a power, you want to get that by itself. So in this problem, if we add 6 to both sides, you get 3 to the x equals 9. Now, you're probably sitting there thinking, well, we know that 3 to the second power, or 3 squared, is 9, so can't we just do x equals 2 and be done with it? And I would say, yes, you could do that. In 99.9% of cases, you can just do that. But I want you to see the other way you could do it, because it's not always going to be that simple. We're not always going to have 3 to the x equals 9. We could have 3 to the x equals 21, or 2 to the x power equals 17, where it's not going to be a whole number. So that's why it's important to be able to do these steps when you get those problems like that. So the second step is going to be change to a log. So let's do that. We'll start with the word log. And our base is 3 of 9 is going to equal our exponent, which is x. So then we will use what's called the change of base formula. And what that allows you to do is to use your calculator. We've seen that our calculator does not have a base when you type in log. If we type in log, there's no way to type in the base. Type in 9, we get 0.95. We type in log and we type just the base, we get 4.77. So instead of that, what we can do is use this instead. So we can do log of 9 divided by log of 3. And remember, when there's no base written, it's an invisible 10. So that means we can use our calculator, because that also has an invisible 10. Make sure you close the parentheses. And you see that we get 2, which is what we would have suspected we would get. So, oh wait, that equaled x. And then we did the formula and got x equals 2. So the change of base formula allows you to use any base. So we had log base a of b is equal to log, let's switch these to make it a little bit nicer to deal with. We'll call that one b and that one a, because b, we've always used b for base, so let's just keep it that way. So we have log a over log b. Notice b is your base, it's in the bottom of my fraction. We could also do ln, or the natural log of a over the natural log of b, because those are log base e's. ln is really the same as log base e. So yes, I could have done ln of 9 divided by ln of 3, and we still get 2. And a lot of people will only use ln just because they think it's easier. it doesn't really matter. You could use a log button or the ln button. I'm going to be using the log button. So if we look at some problems down here, we already have the base by itself. 8 to the x power is all by itself. So we're going to switch this to log form. So 8 of 20 equals x. So in our calculator, well, let's write it out first. We'll have log 20 divided by log 8, and that will equal x. So log 20 divided by log 8, and that's going to be 1.44. So 1.44 is equal to x. Now in letter B, we don't have our base to some power by itself. We have this plus 4. So we have to deal with that first. We can subtract 4 from both sides, and then we get 10 to the 3x equals 5. And now we can change this to a log. So log, your base is 10, your other number here is 5, and that's going to equal to our exponent, which is 3x. Notice that there's a 3x with it, not just x, meaning that we will still need to do some work after we use our change of base formula. So in the calculator, I'm going to do, well, we should write it down first so we always remember it. So now log 5, close the parentheses. That's a common mistake people make, is not closing the parentheses. And we get 0.6989. So let's just round that up to 0.7. So 0.7 equals 3x. And then when I divide both sides by 3, I get 0.23 is equal to x. And that's what we get there. So this is why I said it is important that you know how to change from exponent form to log form and from log form to exponent form, because this is what we've been doing this whole unit. And without knowing how to do that, it's going to cause some real struggles for you. So let's look at the next page. And we don't have our exponent and base by itself yet, so let's subtract 7 from both sides. And that will give us -5 equals 4 to the x power. So now that we have 4 to the x power by itself, we can change this to a log. So log base 4 of -5 equals our exponent, which is x. Well, if you go to your calculator and try to type this in, you're going to get an error. Let's look. Log -5 divided by log 4. We get error, no real answer. So we say error, which means there's no solutions. And remember, we talked about this the other day, that you can't take the log of a negative number. That's why when solving log equations, we have to plug x back in. You don't have to do that for exponential equations. You don't have to plug x back in. But we may get a situation where there's no solution. And here, we can't take the log of a negative number. So this had no solution. Now letter D, we need to get our exponent by itself, which in this case is e to the -x power. That's what we have to do. So first we're going to subtract 12 from both sides. And that's going to give us 2 times e to the -x power equals 6. Divide both sides by 2. we're going to be left with e to the negative x power equals 3. So now that we have our base by itself, we can convert this to a log. Our log is base e. Our other number is 3. And our exponent is negative x. So from here, there's two things you could do. You could use a change of base formula and say log 3 over log e equals negative x. Or you could do ln of 3 equals x in your calculator. Because we do have an ln button in our calculator, it's right here. So if I do the ln of 3, I get 1.09886, which we would round up to 1.1. If we use the change of base instead, so log 3, close parentheses, divided by log e, the e button is second and the divide key. So if I were to do that, look, I get the exact same thing. So some people are just always going to use a change of base and say, you know what, I'm just going to use change of base, log 3 over log e will give you my answer. But if you recognize that log base e can be substituted with ln, that might get you the answer a bit quicker. This is going to be negative x, I'm sorry. So that's going to give us 1.1 equals negative x. Well, we need to divide both sides by negative 1 to get rid of the negative sign. So that's going to give us negative 1.1 equals x. Now letter E, there's a lot going on in letter E. We need to get 4 to the x minus 6 power by itself first. So we'll subtract 10. And that'll give us 8 times 4 to the x minus 6 power equals 80. We'll then need to divide both sides by 8. And when you do that, we get 4 to the x minus 6 power equals 10. Now we can go and change this from exponent to log form. So we'll type in, we'll change this to log base 4 of 10 equals our exponent, which is x minus 6. So we're going to have to deal with that minus 6 once we use our change of base formula. So then we're going to have log 10 divided by log 4 equals x minus 6. When I type that into my calculator, log 10 divided by log 4, I get 1.66, and that equals x minus 6. Well, we don't have x by itself, so we have to add 6 to both sides. So we get 7.66 is equal to x. Now, letter F, all right, we'll start by subtracting 5 from both sides. And we get 5 times 2 to the x power equals 20. And if we divide both sides by 5, we get 2 to the x power equals 4. And like I was saying earlier, you might be able to look at this and realize, oh, x has got to be 2 because 2 to the second power is 4. If you can do that, then you're good to go. You don't need to do anything more. You don't need to go any further. You can just say, oh, I know x is equal to 2. But if you don't, you could still do your changing to log form. And you could still do your change of base. Log 4 divided by log 2 equals x. And when you type that in your calculator, you're still going to get 2. So don't worry about being able to recognize that, oh, 2 to the second power is 4. This change of base formula will always work. All right, so I want you guys to try letters G and H. Notice in letter G, you have a 3x as your exponent, so you're going to have to maybe look at letter B up here to see what happens when you do. You have like 3 to the x power in your exponent. And then the other one is kind of like letter A right here, where you're just going to change that to change it to log form and then use your change of base formula. So go ahead, pause the video, and when you are done, check your answers and work with mine. All right, so here are your answers and the work that goes with it. So one of the things you could do is double check your answers. And what I mean by that is if you look at letter H, if I do 2, let me clear all this, 2 raised to the 6.7 power, plugging x back in, I get 103.968, so on. Now, you might say, well, it's not exactly 104, but we're pretty close. When I did this problem, I didn't get exactly 6.7. I got 6.7, 00439, and so on. And when I rounded, I lose that information. If you try the other one on the other side, letter G, and I do 3 times 6 raised to the 3 times 0.41 power, I get 27.18. Still not exactly 27, but pretty close. So we're going to use 2 decimal places when we round, because watch what happens if I would have just done 0.4. Instead of 27, I get 25.76. That's off by a good amount. So let's always round to 2 decimal places if we can. The reason why I didn't do anything after 6.7 is because the next decimal place after the 7 was a 0. So you didn't need to go any further than that. So let's round to 2 decimal places, and you can always double check by plugging in your answer, and you will get something very close to what you should get, or what's on the other side of the equal sign. So hopefully, the more that we're doing this, the better you are getting at converting from log to exponent, or from exponent to log form. This is going to keep coming up for us. So thanks for watching the video. Make sure to like it and subscribe.